This is Andrew Wicklund with Project Risk Consultants. We're going to go over the sixth step of the risk analysis process. So we've got a 7-step process. We've gone through importing the file all the way up through loading our uncertainty and our risk events. Now we're ready to run our risk analysis. So steps 4, the uncertainty, step 5, the risk events, and now we're on to step 6 up at the top of the risk menu and running the risk analysis. So this module is just going to focus on the risk analysis options and walk you through those. So I'll go ahead and click on risk analysis options, and notice we have 3 tabs. So the first one, we'll just take this on each one, the tabs left to right, and we'll go down the data top to bottom. So first of all, you've got your calculate duration and cost sensitivity. Those are relative to the tornado charts. You do not need to set that up front. You don't need to have it do that for you. You can right click on the activities that you want to generate that for after you've run the analysis. I would generally recommend unchecking that. Let it run through the analysis quicker that way, and then when you're ready to pull those tornado reports, it'll be, then it'll have to calculate them at that point. The next section is calculate risk percentiles. I've got that check marked. I'm going to click on the percentiles button, and what this allows you to do is actually create user-defined fields and columns for percentile data. So if somebody said, I wanted to make a probability 50 level schedule, I want to see what that looks like, or probability 80 level, I would click on duration and do 80%, and it can do a field for me now for P80 durations. So if I were to put these P80 durations back to Primavera P6 or Microsoft Project, I could actually replace the remaining durations with the probability 80 durations and have a P80 version of the schedule. So from a theory point of view, you normally don't want to work to a P80 because oftentimes the work will fill up the time. However, that being said, if there was a reason that we want to work to a P50, we took our P50 durations over, and then we created a P50 schedule. There might be a reason to do that. You might want to just look at your P50 and P80 overlay bars. That's where you would do that. So this will actually create columns that you can either view in Primavera Risk. There's a Risk Outputs tab that by default will show you a P50 and a P80 overlay. So that's what that tab does for you. Save the resource data. Depends on the type of analysis you're doing. If this is a resource loaded model, etc., you may want to do that. The probabilistic cash flow data. If you want to generate the probabilistic cash flow chart, you have to check mark this option in advance. Now when I click this button, I'm looking at all cost. Possibly I might be looking at just labor. So I don't want to run it for probabilistic cash flow. I'm actually going to run a probabilistic resource flow. I could get my time phased resource curves for maybe man hours for labor, or any of these different resources, including cost in general. So you have to, when you run this, check that box. If you don't check the box and you want to run that report later, you will have to rerun the analysis. And then you've got save the net present view, internal rate of return value. So depending on the type of analysis you're running, once again, you may check mark those. The typical risk analysis, you're not going to use that. Probabilistic cash flow may or may not use. Same thing with the risk percentiles. The rest, the resource data you may want to check. These two up top, it'll take longer to calculate, and you might use 2 or 3 different tornadoes anyway, so you're probably going to have to recalculate the tornado charts as it is. The second box is for the analysis option. The first one is how many iterations. The question on that is obviously you type in a number there. The question is how many iterations to run. There's no correct answer on that. However, when we look at the histogram chart, it will tell us whether the iterations have converged or not, and it's important that your curve has reached convergence. If you don't run enough simulations, basically, you didn't run enough. So it's kind of like when you flip a coin in a casino. If I flip a coin twice in a row, I could hit heads twice. I could flip heads 5 times in a row. But if I run it 1,000 times, law of averages is going to take over. I'm going to get about a 50-50. Same concept here. Generally, it takes a few hundred iterations for it to converge. A good rule of thumb is run 1,000 or 2,000. Different documents say anywhere between 1,000, 10,000. Um, you know, at a certain point, once you've run enough, you can keep running them forever, and the curve isn't going to change really. The data is not going to change because you've sampled enough. So the Latin hypercube sampling, it's just another sampling method. It samples things slightly differently. It converges slightly faster. Monte Carlo will be, if you uncheck this, it will use a Monte Carlo sampling. Monte Carlo is just a complete randomness. Latin hypercube in layman's terms is kind of like forced randomness. It kind of puts things in buckets so it converges quicker. It kind of nudges along the law of averages. It was designed when people used it when the iterations weren't they didn't run so fast on a computer. We didn't have the machines that we do now to where 1,000 iterations is no problem. That's why we would use Latin hypercube sampling. At the end of the day, the data sets are going to converge about the same way. The next box is analyzed until converged. We talked about convergence. If you want, you can set up a convergence metric. I can click on this. Like convergence is plus or minus 1% over 100 consecutive iterations. If my curve didn't change plus or minus 1% over this 100, I know it won't over the next 100, so I can say it's converged. We generally won't run it until convergence. We'll generally go above and beyond. The reason is for the tornado charts, outliers will have a bigger impact if you don't run enough iterations above and beyond that. That's why we say 1,000 iterations, or even depending on the size of the file, 2,000 is a good rule of thumb. But if you run 1,000 iterations, generally the outliers don't have the massive impact they would as if you had only run 200 iterations. So show the step-through analysis options. If you want to watch the simulations run, you want that checked, so you'll be able to see it as it's simulating. Set own seed for random number generator. If you want to repeat the analysis, you want to set that number in, or else it's going to use your clock on the computer to set the seed number. So if I ran the same simulation twice, I might get slightly different results unless I set the seed number, and then it's going to start the random number generator from the same point. You can restore all ignored tasks before the analysis. So if you've checked marked to ignore tasks, you can unignore them for the analysis. You can choose to ignore correlation between risks. So for the analysis, normally you're setting up the correlation for a reason, but if you want to see the difference on what correlation does do and what it, with the difference with and without, you can run a curve for each and see the delta between the two. The next one, you can see resource level. You can have it resource level per iteration. It is a very time-intensive analysis at that point, because what it's doing is taking all the random numbers, filling those out, and then doing a complete resource level for every iteration. So if you do that 1,000 times, all the random numbers, calculates the CPM network, then it resource levels the network, and then it goes to the next simulation. It can be a very incredibly time-intensive analysis. Also, it's one where maybe at a certain point you're going into too much detail unless you really you have a good strategy behind it. So it can be done. The thought process is sometimes do we need to go into that level of detail? Resource leveling, you're always letting the computer make some decisions for you based on its leveling algorithm as well. So you're putting a lot of faith in the machine at that point, so you want to make sure your model is very solid and bulletproof at that point. So it is definitely doable, very time consuming, and it takes a lot of work on the user's end to make sure that you've done it appropriately. After the analysis, it's going to show you a graph unless you uncheck that. I'm going to leave up so it shows me the distribution graph. I can uncheck that. And then there's a warnings tab. Now these warnings aren't saying that the item is wrong. It's saying, hey, look at this. This is a flag because it's showing me something is not maybe appropriate. So the first one is the most likely is different from the deterministic. So I have a remaining duration, but I put a most likely that was different. So all it's saying is, hey, your schedule isn't scheduled to the most likely if the remaining duration isn't your most likely. Did you know your schedule is not the most likely value? So, and that happens a lot of time. You're dealing with schedules that are overly aggressive. You're dealing with schedules that maybe have contingency built into them, and the most likely is not the same as the remaining duration. Politically, that's a hard sell sometimes, but in the real world, we know that's accurate. So if you really want value from a risk analysis, we should try and use the minimum, likely, and maximum that are really true, and not just assume that the schedule is flawless. Um, the deterministic value is outside of the range. That's another one where you said it's a 10-day activity, but when we looked at it as a team, we said it's going to take 20 to 30 days. That one means it's so far off that the remaining duration's not even in the range anymore. So that's another one where it's kind of, uh-oh, our baseline schedule or our working schedule isn't correct. If politically or baseline wise or any, beyond politics, if we could go back and adjust the schedule, we actually should at that point go and say, okay, if the team says it's 20 to 30 days, it shouldn't be 10 days in the schedule because we're fooling ourselves. Risk is assigned to a task with an actual finish. If it's finished, it's 0 duration. You can't have risk on it. It's before time now. It's just going to ignore it though. It's just saying, hey, did you know it was on there because you either put it somewhere where it shouldn't have been, or why is it there? And the last one is beta per distribution is symmetrical and a shape value has been entered. And you can actually go into one of these and play with the beta per value. And I can try and, if I change this to symmetrical and I do 14, 15, 16 and try and change the shape, you can see warning shape perimeter is going to be ignored just because of the way that beta pert is. So you can see how that samples there. So it's a quick overview of the risk analysis options. You're not really going to have to edit this too much. The risk percentiles, the probabilistic cash flow, those are two areas you might. And then the number of iterations. I generally don't use the Latin hypercube unless I'm doing some sample scenarios up front. Because Monte Carlo is the buzzword, I go ahead and use Monte Carlo sampling method. When I'm doing quick what-if scenarios, though, with a large group of people, I'll usually turn on Latin hypercube sampling, maybe do 300 iterations, so at least I can get them something representative quick. I know we can only get the right people in the room for so long, so I want to make it as fast and hard-hitting as possible. So if I make them wait for 1,000 iterations, that's not going to be an effective use of their time. So I definitely want to get things done as quick as possible. So that Latin hypercube is actually a decent metric, or a decent option as well to use when you do want it. If you use that for your final reports too, not a problem at all. Should give you about the same results. Just sometimes when people see the word Latin hypercube, they get a little bit worried that, oh, we're supposed to be doing a Monte Carlo. Why are we doing Latin hypercube? This isn't right. So so that's an overview of the options. We're going to leave this step through options checked on, and then we're going to go on to actually running the analysis in a separate module.